Heyo y'all, this is Chrissy coming at you with some examples. A 2 centimeter tall object is 15 centimeters in front of a diverging lens that has a minus 20 centimeter focal length. Determine if the image is real or virtual and the height of the image. Let's start by drawing it out. We want to find if this image is real or virtual. We do that by finding the sign on S prime. The equation that we're working off of is 1 over S plus 1 over S prime equals 1 over F. Rearrange that. 1 over F minus 1 over S equal, we can plug in minus 1 over 15 centimeters. 1 over S prime equals minus 7 over 60 centimeters, which gives us that S prime is equal to minus 8.6. That's centimeters. Since S prime is negative, that means that our image is virtual. We now want to find the height of the image. We do this by finding the magnification. Magnification, so we have M equals minus S prime over S equals H prime over H. H prime over H equals minus S prime over S. H prime over 2 centimeters equals minus negative 8.6 over 15. And we get an H prime of 1.1 centimeter. Since this height is positive, that means that the image is upright. We can draw it in there, since we know its position and its height. The height is smaller, should be somewhere around here. And that's what we're looking for. A 3 centimeter tall object is 45 centimeters in front of a convex mirror that has a minus 25 centimeter focal length. Determine if the image is real or virtual and the height of the image. Pretty similar idea to before. First thing that we want to find is this image real or virtual? We determine that by finding the sign on S prime. We do that with 1 over S plus 1 over S prime equals 1 over F. Rearrange that. Over S prime equals 1 over F minus 1 over S. It's going to equal 1 over minus 25 centimeters. We've got to keep that minus in there. Minus 1 over S, 1 over 45 centimeters. 1 over S prime becomes minus 14 over 225 centimeters, because I like to actually write out the fractions. S prime equals minus 16.07 centimeters. Since this S prime is negative, That means that it is virtual. Now we want to find the height of the image. We do this using the magnification. M equals minus S prime over S, which equals H prime over H. H prime over H equals minus S prime over S. H prime over 3 centimeters equals negative minus 16.07 over 45. We get H prime to be 1.1 centimeters. This height is positive, which means that the image is upright. We also have a position for it, so we can draw that. The height is smaller, so it would be something like that. Let's do some practice with ray tracing. You're going to want 3 things to do this. Let's start with 3 different colors and a straight edge or a ruler. There are 3 principal rays that we use when tracing light through a lens or a mirror. The first ray that we use is going to start parallel to the axis, and on the other side of the lens, it goes through the far focal point. The second one that we have goes through the center of the lens. This one does not bend. The third one that we have goes through the close focal point. This one emerges parallel. All of these bends happen in the lens. Let's start with our first one. We start at the top of the arrow and we line it up. Draw the ray to the center of the lens. So this is the one that starts parallel, and then it's going to go through the far focal point. You want to draw it out further than just that point. That's our first one. Our second one is going to go from the top of the arrow right through the center of the lens. This one does not bend. Our last one is going to go through the close focal point. And then it will emerge parallel. In theory, all 3 of these rays should meet at the same point. Usually they get pretty close, but it gives you an idea of where it's supposed to be. Where these 3 rays meet is where the image is formed. That is our image. On this, we've placed the arrow at 3 different positions. We have beyond twice the focal length, between twice the focal length and the focal length, and in front of the focal length. These are the 3 scenarios that you'd want to be able to draw for each type of lens or mirror. This one on the bottom is a little different from the top. Let's go through it together. We're going to start out like we did before, with our green for our first ray. We're going to go out parallel, and then we are going to go through our far focal point. For this second one, again, we're going to go through the middle. You might notice something about these lines. They are not going to meet on this side. They're moving away from each other, unlike what we had up here, where they were all converging at a point. These are all moving away from each other. Let's draw out the last point. This one is going to go through the close focal point. The weird thing is, though, the close focal point is behind it. We still have that ray, though. We're going to align it like that. So our line is still going to be coming up as though it was going through this focal point here. It's going to hit the lens, and then it is going to emerge parallel. These three rays are clearly not going to interact with each other over here. Instead, when you see something like this, where all of the rays are going away from each other, you actually trace them back to the other side. So, for example, our eye, remember, is tracing them back. So we're going to expand these rays. You do this when they are not meeting each other on the opposite side of the lens. In theory, these should all line up, but sometimes you kind of have to force one. They all meet at this point. That means that our image is going to be something like that. Shouldn't be distorted, though. It's going to be something like that. It's magnified. It's larger. Try to do the middle one on your own. This middle one leaves us with a real and inverted image. This first one is also real and inverted. The one at the bottom is virtual and upright. You can tell if it's virtual because that is where the rays diverge after the lens, but you trace them back to meet up at a point on the same side. We can work with some other lenses in the next video.